Hi everyone, I'm Chandrasekhar Bollineni and today I'll present MSDS 692 Fall 2025 Practicum project, which is a job board vision assistant that combines computer vision and machine learning to solve a real world problem. A little bit about myself. I'm Chandrasekhar Bollineni, an international master's student at Regis University. I have over 10 years of IT experience in India, where I worked as a data scientist, data engineer, and analyst across both product based and service based companies. During my master's, I have developed a deep interest in computer vision research, which led to create this job board vision assistant project what we are building today and why. Let me start with a personal experience that motivated this project. Months back, I was looking for an internship. I spent around countless hours, day after day, shifting through hundreds of job postings on various platforms like LinkedIn, Indeed, and many other platforms, etc., etc. I'm not just looking for a job, but trying to find the perfect role. Okay, while also trying to understand what skills are truly in demand, what companies are actively hiring, and what salary ranges are realistic for my experience. It's really time consuming, repetitive, and often overwhelming process. So that is where I've come up with a job board vision assistant. My goal was to build an intelligent system that uses computer vision and machine learning to automatically analyze these job postings. It's designed to extract key information, identify the trends, and provide insights, making the entire process smarter and faster. What is the research here? How can we automatically extract and analyze job market intelligence from visual job postings? What is that I've done? What we will be covering today? Firstly, we will look into the data collection and its challenges. This is where I gather job posting data from various online sources like Kaggle, LinkedIn, using some automated scraping techniques like Selenium or Playwright. Next, we will look into how I transform a raw screenshots to meaningful data using computer vision. Here I have used advanced image processing and OCR, and also called as optical character recognition, to extract meaningful text and information from screenshots of job postings. Following that, I have implemented machine learning. This is the brain of our system where I have trained models to classify job roles, predict seniority levels, and even estimate salaries based on that extracted text. Finally, we will discuss the results, what is the impact of automation, and what is a demo. I will show you the benefits of this automation, including personalized email reports and interactive dashboards, and give you a quick look, a live demonstration of the system in action. Talking about the data challenges, before I go into the solution, it's crucial to understand the challenges I have faced in gathering job market. My first major challenge was LinkedIn's robust anti-bot protection. Okay, while taking the screenshots, LinkedIn blocks bots. Okay, while automatic screenshots, I'm saying. So gathering job post data without being thought is hard. I had to make my tools behave like human users. Second, job postings are often presented as visual images with complex and varied layouts. Automatically extracting structured information like job titles, company names, locations, and salaries from these different visual elements is a significant computer vision challenge, far beyond just simple text extraction. Third, websites are dynamic. Their structures constantly change, which means automation tools like Selenium and Playwright require highly customized and frequently updated scripts. Even minor website updates can break our scraping logic, demanding continuous maintenance to ensure consistent data flow. The raw job data often has a problem. So many job posts are missing information, use different formats, or give different levels of details. Okay, that makes my machine learning models less reliable. So cleaning the data is very important. Fixing the data issues is very important. These data are essential for building a strong job board vision assistant and for getting useful job market insights. So overcoming these data collection challenges was very essential for building the platforms which can extract job market intelligence from visual job postings. Data collection, how I solved it. Having understood the challenges, I have used two sources. For LinkedIn, I built a playwright automation that could get past anti-bot protections and collect live job postings, for example, role, company, location, post date, in various targeted screenshots like a job detail screenshot, pay information screenshots, job attribute screenshots, and a detailed page screenshot. I've also pulled a large job market data sets from Kaggle. I have to get salary figures, full job descriptions, and company information. Combining these sources gave me a bigger, richer data set to build a machine learning model. Now, let's dive into the computer vision, the very core heart of the system, which is computer vision approach. I've used computer vision approach to turn LinkedIn job screenshots into clean data. First, I ran EasyOCR to read the text. Then I have improved the images with OpenCV, removing noise, adjusting colors, and separating text from background. So EasyOCR can read them better. Combining EasyOCR plus with OpenCV preprocessing gave me about 98% accuracy, producing reliable JSON output for my machine learning models as an input. Small example, as you can see, the ML engineer job code after using OCR image processing and extracting, the final output is a JSON with well extracted fields from the inputs. Talking about now, let me see how I have transformed raw job postings into structured usable data. I've used easy OCR text extraction to read text from LinkedIn job screenshots. Okay, I have got like 98% accuracy in extracting the information from each image, like job title, company, location, all these details. Okay, I have merged this extracted data with Kaggle datasets, validated it, and saved everything as clean as a the final output, which is a JSON, which is an input for my machine learning models, right? And so, what are the challenges I faced during my encounter? So, real world job screenshots got several computer vision problems that we need to fix. Images come from different browsers and devices, so quality, resolution, contrast, clarity varies and makes text harder to read. Job postings also have complex layers, overlapping text, mixed font sizes, and many elements. So, I must detect and separate text regions correctly. After extracting the text, I validated it to remove noise and irrelevant bits and keep only key job values. Finally, I've handled many font colors and backgrounds that can confuse the OCR. By solving these issues, okay, in computer vision, the job board platform consistently extracts job market with high accuracy, enabling data-driven insights, and also it is good for recommendation making. Talking about the next machine learning approach, after cleaning and extracting the job, I've trained models to turn the data into useful insights. I've used random forests to classify job postings by text. I've also used rule-based logic for tricky cases, and feature engineering picks the most important data from each posting, which helps models perform better. When I have a very few labeled examples, I have used data augmentation and transfer learning so the models still learn well. For missing salaries, I have used rules and imputations to estimate ranges. Altogether, with this setup, I have achieved about 98.6% accuracy in extracting job market insights from the images. Um, what are the challenges I faced and how I've solved it? I have got two major ML problems. First, there was a little bit label training data. I've solved this by using transfer learning and creating my own labeled examples with a custom annotation pipeline. Second, many job posts lack salary information. To handle that, I have built a hybrid system. Rules extract salaries or when clearly present, and machine learning predicts salary ranges from job title, location, and seniority whenever the information is missing or needed. These steps help my models reach about 98.6% accuracy in extracting and classifying job data. So talking about what I did post doing all this. Once I built my machine learning model, I've automated the entire workflow and created personalized email reports that summarize the job findings. Each email shows that how many jobs were found, the date of the analysis, and confirms that our ML models were run. It lists specific job day matches, for example, data scientists at Meta with the location and the location, salary information, and posted on all these details. The report also highlights trends, tops, opportunities, categories, and company insights, and includes links so that user can quickly view or apply. This gives users useful job intelligence automatically without any manual effort. So here is a small demo to showcase what I've done. Hi everyone. I'm Shekhar Bollineni, and I'll be showing the job board assistant, vision assistant. Let me start by running a Python application. First, I will run a Python app.py command. So there is the terminal, as you can see, and it will start a web server, basically the development server. Once I go to the web server, which is the development server, okay, I will get this interface. We have a complete automation system that process job postings from LinkedIn using computer vision and machine learning. As you can see the web dashboard. Okay, once I do that, okay, I will do the start automation thing. By default, it will be data engineer with the PyJobs. But I can change it. As you can see, I'm changing it to data scientist, and I'm keeping the jobs as it is. And just I'm trying to click start. Once it does, okay, it will start collecting the data, and so OCR will be initiated. The system automatically captures LinkedIn job postings, extracting text using OCR with very good accuracy, and saves the complete data to JSON files. As you can see, we can see the data collection progress and OCR extraction progress, and I can also show you the JSON file extraction. And then we are doing a machine learning part, and our machine learning models analyze the data, predict job categories and salaries, and also it can give so with a very good accuracy. It automatically sends a personalized email reports. As you can see the email I will show in the next slide, where you can see the ML processing, model training success, and also email has been generated, and you can see the results and dashboards. These are dashboard which I'm trying to show. So it has like email notifications received and dashboard visualizations, and also it is showing some key metrics and insights. This is a small highlight, I mean, like how the technical part has been achieved with the 98% OCR accuracy, with 98.6% ML accuracy, and it is automatically generating the email reports, and it's all real-time processing. Thank you for the demo. Hi. So my job board vision assistant isn't just for our job seekers. It helps businesses too. Like HR teams can speed up hiring and get real-time market insights. Recruiting agencies can find talent and match candidates more efficiently. Job boards can add automated job analysis and better such tools. The system can be designed to scale in the cloud and can offer API integration so partners and third-party apps can use it with ease. If I get more time to work on this, I would like to extend this to build on more job boards with a better machine learning models for more insights. Um, I would like to thank you for your time and for your attention. I'm happy to answer any questions you may have. Please feel free to reach out via email if you have any further queries. Thank you.